This is example 2 from lesson R.2. We have two expressions to be simplified involving exponents, and we'll be using some of the properties of exponents from the previous slides. Okay, so we're going to grab our pen here. In A, we have 3w to the negative 3 times 5wt to the positive 5, and all of that squared. All right. So what I'm going to do first is I'm going to take all of the 3w, both of those bases are being applied to that negative 3 power. I'm going to take the reciprocal of that. This is going to be 1 over 3w. And all of this is what I'm going to be raising to the positive 3 power. All right. Now, in the second part of this expression, I'm going to take that 2 exponent and I'm going to apply it to the 5, to the w, and to the t to the 5th. Now, this is going to be 5 to the 2nd power. This is not 5 times 2. And then we're going to have w to the 2nd power and t to the 10th power. Because remember, when one base has 2 exponents attached, we're supposed to multiply those together. All right, so this is going to turn into 25 w squared times t to the 10th, okay? Over here, now I'm going to take my 3 exponent and I'm going to apply it to all 3 of my bases in parentheses here. So I have 1 to the 3rd divided by 3 to the 3rd and w to the 3rd. So this is going to give me 1 over 27 w to the positive 3 power, and this is being multiplied by 25 w to the 2nd power t to the 10th power. All right, now if we write this all as one fraction, we will have 25 w to the 2nd power t to the 10th power divided by 27 w to the 3rd power. And we're almost finished here. I notice I have w's in the numerator and w's in the denominator, so this fraction can actually be reduced. And I have 2 w's up here on top, 3 w's down here on the bottom. I can cancel both of those with 2 of those and leave me with 1. So that's going to leave me with 25 t to the 10th on top, and then 27 w, or w to the 1st if you want to put that exponent on it, on the bottom. All right, now for B, we have a negative exponent applied to everything in parentheses here. The best way to get rid of that, well, is what we've been doing. Take the reciprocal of your base here. So all I'm going to need to do to turn this into a positive 3 exponent is take this whole fraction and turn it upside down. That's going to give me 13 times c times d to the positive 8 over 26 c to the positive 5 d to the negative 2. Keep that negative 2 because we didn't move just the d by itself. We turned the whole fraction upside down. And now all of this is going to be raised to the positive 3 power. Now, at this point, we can apply that 3 exponent to all the bases in the parentheses, but I suggest that we reduce the fraction first because then we'll be applying that exponent to bases that are a lot smaller numerically. Okay, so let's take a look at this. Let's see. 13 can actually go into 26 2 times, and 13 can go into 13 1 time. So I know I have a half left. Okay, I have 1 c up here on the top and 5 of them on the bottom, so this can cancel out with one of those and leave me with 4 down here. Okay, and I have 8 d's on the top. I have negative 2 d's down here on the bottom, and to make this positive, I would actually bring both of those up here on the top. So if I have 8 d's and then I bring 2 more up, that's going to give me 10 d's altogether up there, and this is raised to the 3rd power. And now what I'll do is I'll take that exponent and I'll apply it to each one of the bases in here. So we've got 1 to the 3rd, d to the 30th power, 2 to the third, and then c to the 12th. And then when we simplify this, we'll have 1 times d to the 30th divided by 8 times c to the 12th. And you don't have to have that 1 there. You can turn this into d to the positive 30 over 8c to the positive 12 power. And we have the same thing there. And that's that.